So this video builds on the previous one, looking at the relationship between Pascal's triangle and binomial expansions. So from that video, we can expand and find things such as a plus b to the power of 3. So we saw that that was a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, we can use that to help us find all sorts of other expansions to the power of 3. So in this first example, let's have a look at 2x plus 3 all cubed. Well, look, we could just say that that 2x is a bit like an a, and that 3 is a bit like a b, right? So let's write down that relationship. A equals 2x, and let's say that b is equal to 3. So now, if we write down what we know is to be true about a plus b cubed, so that is that it's a cubed plus 3a squared b plus 3ab squared plus b cubed, I could now write that with my 2x and my 3 replacing the a and the b. So that is going to be 2x cubed plus 3 lots of 2x squared times 3 plus 3 lots of 2x timesing 3 squared plus 3 cubed. So that's swapping it all out. Okay, now we can start simplifying this. Well, 2x cubed will be 8x cubed. 3 times 3 is 9. And so we've got 9 times, let's write another extra line. I'd say 9 times 4x squared, which is the 2x all squared. Then we're going to have, well, 3 squared is 9 times 3 times 2. We're going to have 54x for this term, and then we're going to have 27 as 3 cubed. And then finishing this off, we'll have 8x cubed plus 36x squared plus 54x plus 27. So what we've done there is we have used our knowledge of Pascal's triangle and the fact that a plus b all cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed to expand something very, very different. Right, let's have another look at another example, very, very similar. Okay, so let's have a look now then at x minus 5 all cubed. So with this example, let's say that x is our a and b is minus 5. So we need to include that minus sign when we do this. So if we, again, start by writing out a plus b all cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed, we can now start swapping those things in directly. So this is going to become x cubed plus 3x squared times minus 5 plus 3x times minus 5 squared plus minus 5 cubed. So we can simplify some of this. We're going to have x cubed minus 15x squared plus 75x minus 125. So our expansion there is there, done. Right, so now let's progress and let's look at a more challenging example. So we'll do this together. We're going to find the fifth row of Pascal's triangle, and then we're going to use it to find the binomial expansion of x minus 2 over x to the power of 5. So first of all, if we find the fifth line, let's just quickly, and it doesn't take a second, just write out Pascal's triangle. So that is up to the fourth line, so one more. Okay, so this is the line we need. Now, I am going to start by saying that a can be x, right? So our a is x. B is going to be minus 2 over x, and we're going to do the same process. Now, we can make lots of savings here and sort this out very quickly. So if we write this out with some spaces, 1, 5, 10, 10, 5, 1. And then what I'm going to do is remember that relationship from the previous videos with A's descending and B's increasing. Well, we're going to use that relationship. So we know that if we are on the fifth line, we're going to have a to the 5 on this term, a to the 4, a to the 3, a squared, a, and then there'll be no a's at all on that last term. And then in terms of the b's, if I start from the right, okay, we're definitely going to have b to the 5 there. Okay, b to the 4, b to the 3, b squared, b, just b to the 1 and b to the 0, so no b's at all there. And we can join these up, look, okay? And we know this is how we can very quickly put together a binomial expansion. All right, so now what we're going to do is we're going to substitute our values of a for x and our values of b for minus 2 over x. So if we do that, we're going to end up with the following. X to the power of 5 plus 5 lots of x to the 4 times a minus 2 over x. This next term will be 10x cubed minus 2 over x squared plus 10x squared minus 2 over x cubed plus 5x minus 2 over x to the power of 4 plus minus 2 over x to the power of 5. And I've kept them separated because you can run into problems of negatives and squaring and cubing certain coefficients. So we'll take our time and do it slowly. Right, now we can simplify again each one of these and see if we can cancel some things out. So x to the 5 can remain the same. So we're going to end up with a minus 2 and a 5, so a minus 10. And the x to the 4 will cancel with one of those x's on the denominator of that fraction. So we're going to have x to the power of 3. In the same way, minus 2 squared is going to be 4, and 4 times 10 is going to be 40. So we will have 40 here. We'll have an x squared on the denominator of that fraction there, and that's going to cancel with 2 of the x's from the x cubed, leaving us with just an x, and it will be a positive term because minus 2 squared is going to be positive. So carrying on in this similar vein, we're going to end up with the next term being minus 80x to the minus 1 plus 80x to the minus 3 minus 32x to the minus 5. Now, I've written mine in exponent form, but it would be perfectly acceptable to write this term, for example, as minus 80 over x, or this term as 80 over x cubed. These are exactly the same thing, and you won't be penalized either way. Okay, so there's our answer. Now, let's have some practice at this, and we'll look in the next video at some even more complex problems.